All right, we're doing Mod 2 Day 4. This says, for some strange reason, Mod 4. Change it to a 2. And we're going to do a whole lot of graphs. So you need a piece of graph paper, maybe even two, but we're going to do all of these on one graph. And then we'll group a few others, but most of these are going to be on separate graphs of their own. So here we go. I'm going to be switching back and forth to the graph paper. The first one's the parent graph, and we did that yesterday. So we're going to pull up our graph paper. Again, you're going to try and fit eight on one side of your graph paper. So let me get a coordinate system pulled up. I'm going to put my y-axis there, my x-axis here, and we'll put several on this. The parent graph we did yesterday, you could go back and forth. It was 9 and then 4 and then 1 and then 0, 1, 4, and 9. Plot those points. Or you might remember it, and by the way, you're going to need several colors. Since the vertex is 0, 0, from there, I'm going to enlarge this if I can. From there, the pattern was, because the A value is 1, it was up 1 over 1 to the left and right. From that new point, it's up 3 over 1 to the left and right. And then from there, it's up 5, 1, 2, 3, 4, 5 over 1 to the left and the right. And sketch in your parabola. Oh boy. I'm going to try to be neat, but you know how that's going to work out. And then we'll go back to our paper and we'll do the next one. I'm going to pick new colors for everything. I'll start this one in blue. What's different about today's, you might notice, is that we have these coefficients in front of x, and we didn't have that yesterday. So yesterday, the A value was 1, and now we have different A values that are not 1, and that changes things. To figure out how to graph that, it's not going to be the 1, 3, 5 pattern if the A value is not 1. So we might start for each of them with, oops, I need the pen. We might start with the vertex. It's a good idea to always start with the vertex. Since I don't have any parentheses, there's no left-right shift, so the x value of the vertex is 0. And there's no number off to the right. You could put plus 0. That tells us the y value is 0. And that's true of all of these. The vertex is 0, 0 for all of these. There's no left-right shift, and there's no up or down shift. So they're all going to start at the same place, 0, 0. But then we aren't going to go 1, 3, 5. We're going to need to make a little bit of a table to figure out what that 2 is going to do to it. So I'm going to make a table for each, and then I'm going to erase the table each time. So, oops, I'm trying to color code. So I'm starting at 0, 0. And I need to make a table. My first equation is 2x squared, and making a little table. I'm going to erase this table when I'm done because I need that space. And you only need to pick a couple of x values that are close to the vertex. The vertex is 0, 0, and I want to be close to the x value of the vertex. And you might agree that 1 is close to 0, and 2 is close to 0, and 3 is close to 0. And then we're going to take those values and plug them in place of x, starting with 1, and use PEMDAS, which means I do the exponents first. So 1 squared is 1, multiplied by 2 is 2. If I go too fast, the beautiful thing is this is a recording. You can always pause. We're going to plug in the next x value, which is 2, and we'll do PEMDAS. 2 squared is 4 times 2 is 8. We'll plug in the next x value, which is 3. 3 squared is 9 times 2 is 18. That's probably too big for us to graph, so we're probably not going to graph it. So we're going to plot the points 1, 2. 1, 2 is right about there. And 2, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8 is about there. And that only gets us half of my parabola. But that's okay, because you might remember that a parabola or a quadratic has a line of symmetry that goes through the vertex. By the way, I didn't plot that because it's just too big. That 318 is going to be off my chart, so I'm not going to worry about it. But I've got this line of symmetry, which means this point right here I got, the 1, 2, that point has another point that is 1 unit on the left side of the line of symmetry, because this point is 1 unit on the right side. This point up here, this 2, 8, it's 2 units to the right of the line of symmetry, which means I have another point 2 units to the left of the line of symmetry. And now I have the other half of my parabola. So I'm going to erase this because we're going to need this space later. Oops, it doesn't like to erase very easily. Slowly but surely. There we go. Then we want to observe something. What do we observe? Well, the black graph was my parent, and the bluish purple graph is that y equals 2x squared. It's a little bit messy. Let's erase some of it. And I observed that this one got skinnier. I think that's how you spell it. I'm not a speller. Thinner. It got more narrow. Things like that. The next one, moving straight along, because I've got to go quickly. It's a recording. You can always pause. I'm going to do the next one, which is y equals 1/2 x squared. So go to my worksheet. Remember, the vertex is 0, 0. Oops, I'm going to switch colors. Give me a new color. We'll go with, let's go with yellow. So it's at 0, 0 again, but I'm going to need to make a little table, but this time I have to be a little more careful about my x values I choose. I want it to be close to the vertex, but if I pick an x value of 1, I'm going to erase that because it's not going to work out. If I drop 1 here, 1 squared is 1, times 1/2 is 1/2, and that's a fraction. I'd rather not graph a fraction. So let's pick smart x values that work, and here's the trick. When we plug in those x values, we're going to pick numbers, other x values, that are increments of the denominator, increments of 2, away from the vertex. Since the vertex is 0, I'm going to add 2 to that. The first x value I'm going to pick is 2. Then I'm going to add 2 to that. The next x value I'm going to pick is 4. I could add 2 to that again and get 6. We're always going to add increments of the denominator. You'll see why here in a second. And as usual, I'm making it so sloppy. Let's clean it up a little. Let's plug in our first x value of 2. And then we use PEMDAS. I'll show some work down here. So I have 1/2 times 2 squared is 4 over 1. Multiplying straight across, I get 4 over 2, which is 2. So that's convenient. Let me erase and give some space. Go away, and plug in the next x value. The next x value is 4. I'll plug it in. And down here again at the bottom, I'm going to show my work. I have 4 squared is 16. Multiplying across, I get 16 over 2, which is 8. Or half of 16 is 8. And then 6 is probably going to be too big to graph, but let's see what we get anyway. Plugging in 6, I get 6 squared is, oops, I didn't erase everything I needed to. 6 squared is 36, and half of 36 is just too big, so let's not worry about it. Let me clean some things up. We have our table of values. We'll just plot those. When we plot these, remember, we're only getting half of the graph, and that's fine. That's the plan. Then we'll use the line of symmetry. So I'm going to plot 2, 2, which is right there. And I'm going to plot 4, 8, 2, 4, 6, 8, and the rest will be off the graph. This is half of my graph, my parabola. It's a little sloppy. Sorry about that. Since this point right here, that 2, 2, is 2 units to the right of the line of symmetry, I'm going to go 2 units to the left of the line. It looks like, oh shoot, I don't know what happened there. Sorry, back to it. My hand is hitting things. It looks like it's on the black graph, but that's because I didn't do a great job of the black graph. You can see that I missed my points, my mistake, sorry. And then I'll do this point, which is 4 units to the right of the line of symmetry. So I'm going to go 4 units to the left, and I get the rest of my parabola. And the observations that I notice are that this one looks wider. It got more wide. It got pulled out. Let's move on and try this graph. Again, the vertex is 0, 0. And we'll go, I'm going to clean things up. I'm trying to go quickly because the recording can't be too long. You can always pause. This is a good time to check if you were confused about anything. Here we go. The next one is y equals 4x. I'm using green. Y equals 4x squared, I should have said. And since this one's coefficient, this number here is not a fraction, we don't have to be terribly careful about what y values we pick. They just need to be close to the vertex, close to the x value of the vertex. So 1, 2, and 3 will work fine. So I'm going to plug in my x value of 1. Using PEMDAS, I'll square that first. 1 squared is 1, times 4 is 4. Then I'll use my x value of 2. 2 squared is 4, times 4 is 16. That's already off the charts. 3 is going to be way too big. So let's just see what that gets us if we plot those points. I have an x value of 1 and a y value of 4. 1, 1, 2, 3. Ooh, it's really tiny in here. It's super narrow. And then again, 216 is like, oh, it's way, way, way up here. I don't know. It's super narrow. Gosh, okay, that's embarrassing. Do better than my graphs. It's so hard when I can't rest my hand on the computer. Okay, I super missed it. Feel free to laugh at me. That's so sad. I can't handle it. We can do better. I promise. Okay, I got this. Oh, no. I can't do better, it turns out. All right, so it continues on upward, but also this line, this point, it is 1 unit to the right. I've got another one 1 unit to the left. And let's see if I can get this side of it a little better. Oh, much better. But you can see, even though it's super sloppy, that it's much more narrow. So my observations would be this is more narrow or skinny. I said skinny before. It's even more skinny or more narrow than the 2 coefficient. Let's do the next one, 1/4. Let's pick another color. I feel like I want more. I guess I'm going yellow. Didn't I already use yellow? Talking to myself. I guess I didn't. I made it red. What was supposed to be yellow turned out red. So I'm going yellow this time. All right, this one's a fraction. So after I clear things off, we're going to see what that's going to do to it. We've got a fraction 1/4 x squared. Y equals, oh, seriously? I'm trying to go yellow. Get my colors right. I got this. Y equals 1/4 x squared. We need to pick careful x values. The x values need to be increments of the denominator away from the vertex, which is 0, 0. So I'm going to add 4 to that. That's going to give me an x value of 4. Then I'm going to add 4 again, and that's 8. Add 4 again. It's probably going to be too big, but let's just see what it gets us. I'll show my work down below. Maybe I'll go a little off to the side. So when I plug in an x value, again, I realize I'm going very fast, but you can pause. I plug in 4 and I use PEMDAS. I raise the power first. So I'm going to show some work over here and then I'll erase it. So I have 1/4 times 16, because 4 squared is 16. When I multiply straight across, I get 16 over 4, which is 4. Looking for a y value. Plug in the next y value, which is 8. 8 squared is 64. This seems like it's going to be a little bit too big. And 4 goes into 64 16 times. It's too big, so let's not even worry about 12. Let's graph what we have. We can certainly get the 4, 4. So 2, 4, 4. You can just see right away this thing's going to be wider, even more wide. And then again, using the line of symmetry, I've got 1, 2, 3, 4 units away is where this point is. So I'm going to go 1, 2, 3, 4 units away on the left side. And this guy, turn back. This guy is much wider. So let's go to my observation. Sorry if I'm making you dizzy. So my observation is it's much wider. So the 1/2 was wide. The 1/4 is even wider. Just like the 2 was skinny, but 4 was even skinnier or more narrow. The correct terms, by the way, for that is not skinny. For skinny, we're going to say stretched. And for wider, we're going to say compressed. If you could see me right now, I'll use my arms to demonstrate why it's stretched and compressed. In a minute, we're going to come back to this one. I just want to pause for a minute and let's see what we have discovered so far. So far, what does A do? It either stretches it or compresses it. Stretches or compresses. If the A value is less than 1, that's meaning a fraction. Look back at what happened with the fractions here and here. It got wider is what we said, but we're calling that compressed. The graph is compressed. If the A value is larger than 1, like the 2 and the 4, it gets stretched. I don't know about you, but that feels to me like the opposite of what I might expect it, but maybe that's just me. So now let's talk about the negative. What happens when it's negative? And if you were in class with me, I'd ask you to make a prediction in your head. Make a prediction. What do you think's going to happen? Since we aren't together, I don't know what your answer is, but we're about to find out if you were right. So we have negative 3x squared. Let's go to the graph, clean this mess up. I always have some sound effects. Why not? Clean, clean, clean. Negative 3x squared. You could try to do it while I'm cleaning. Why does it take so long to clean it up? Okay. Continue working. Yes, please. Okay, I'm just going to go purple. So we have y equals negative 3x squared. We need a table. Pick some smart x values that are close to the vertex. Again, the vertex is 0. So I'm going to plug in x values of 1, 2, maybe 3 and see what we get. And plugging in to x1, 1 squared is 1 times negative 3 is negative 3. 2 squared is 4 times negative 3 is negative 12. That's already pretty big. I'm not going to worry about 3. It's probably going to be too big. So let's graph that. Go away. How can I make that? There we go. So we have 0, 0 is the vertex, and then 1, negative 3. It seems to be going downward. And then 2 is negative 12. 2, 4, 6, 8, 10. Oh gosh. Now I've lost count. 2, 4, 6, 8, 10, 12 is right there. And that's a super skinny, otherwise known as stretched graph. There is a line of symmetry that I didn't extend down here. Because of that line of symmetry, we know we have another point, 1 unit to the left, that matches this one to the right. And over here, this is 2 units to the right of the line of symmetry. There's another one 2 units on the left. And there's my wobbly parabola. So what the negative does is makes the parabola flip upside down. So let's put that in our notes. we could say it flipped. In our notes, we're going to say A is always positive. However, the plus or the minus in front of A determines the graph's orientation. Orientation meaning up, it opens up, or it opens down. That's what we mean by orientation. So you notice in all these, we have a whole lot that we're asking you, like the vertex, the orientation, the horizontal vertical shift, all of that, and the orientation. The answer to orientation is either up or it's down. All right, I'm going to stop this video and start another one for some more graphs.